This video will discuss exponents. I note that it is part 1 of the exponents. I'd first like to start with multiplying two common bases together. Here we have x times x. X times x is equal to x squared. I think most of us would agree with that. I have now x to the third power times x to the fifth power, and I say that's equal to x to the eighth power, and one should ask why that is. Well, when we have like bases, we can add our exponents together. So 3 plus 5 is equal to 8. Another way to think about it is going back to exercise 1, or the first question. We could have said that was x to the first power times x to the first power, which would have then given us x to the 1 plus 1 power, which is again x to the second power, or x squared. I would also like to point out that we could have expanded out this second question. X cubed would be x times x times x, and x to the fifth would then be x times x times x times x times x. That's another way to do it. If we're going to do it that way, we should then perhaps put a note that we have 1s as all of our exponents. Once again, add them all up, and we should get x to the eighth power. If we divide like bases, what we then shall do is we will subtract our exponents. So x to the 4 minus 3 power is equal to x to the first power, or more commonly known simply as x. And in the second example, it would be x to the 10 minus 4 power. That will give us x to the sixth power. In these next two examples, the goal that I'm trying to show is, in order to get x, and let's say I start with x squared, the function I'll need to perform on that is the square root of x squared to give me x. Likewise, if I have x cubed and I want to get to x, then I need to take the cubed root of x cubed to make x. This will come up later when we're solving for equations. Some notes about radicals. If we have a radical with a fraction, we can separate that fraction and keep the radical in both the numerator and the denominator. And if we have a multiplication of three numbers, for example, and all those three numbers are under the square root, we can separate those and multiply them together. We should note that if we have the square root of a sum of numbers, that does not necessarily equal the sum of the two separate square roots. Also, we should note that if we have the square of a square root, then what's inside the square root will come out of that square root. Finally, for this video, if we have the sum a plus b and we raise it to the second power, we should note that it does not equal a squared plus b squared. This is a common error. A plus b squared, we should expand out to get a plus b times a plus b. And this brings us back to what we spoke about earlier, which was FOIL, where we take the first and the outer and the inner and the last terms and multiply them all together. And we get the following. And I didn't fully develop that, so maybe I should just write down that that was really a squared for my first terms, plus an ab for my outer terms, plus a ba, which is the same as ab, for my inner terms, plus b squared. And here I note to you the reason we do present these basic rules of algebra, here the commutative property, is so that we can use them in questions like the one we just solved. Namely, right here where we say AB and then we say BA, in order to combine those two together, as we essentially did right there, we combine those two together to give 2AB. We basically say that this BA is equal to, that really equals an AB. And so we have an AB plus another AB equaling 2 ABs.